All right, guys, let's go through question 2 on your worksheets. We're still on worksheet 4. So we have scientist Joseph Priestley that's credited with the discovery of oxygen. He produced oxygen by heating mercury 2 oxide to decompose into its elements. How many moles of oxygen could Priestley have produced if he had decomposed 517.84 grams of mercury oxide? Okay, as usual, we need to write our balanced equation. So let's get that first. So we have HGO, and it says that it is a decomposition reaction. So that means we're going to end up with mercury and oxygen. Okay, mercury, not one of the Magnificent Seven. It can be by itself. Oxygen, part of the Magnificent Seven, needs a 2. And now we need to balance. Okay, so our oxygen is the problem child. So to get 2, I need to put a 2 here. And then that means now I have 2 mercury, so I need to put a 2 here. So that is our balanced equation. Okay, so now let's figure it out. We are starting with grams of mercury oxide, and it's asking for how many moles of oxygen could we make. So we need to go from grams of mercury oxide to moles of mercury oxide to moles of oxygen. All right, here we're going to use the molar mass. Here we are going to use the mole ratio. So let's set it up. We have 517.84, and that's grams of mercury oxide. Let's put it over 1. And then we need to write our first conversion factor, which is going to be the molar mass. If I calculated it properly, grams in the numerator, that means grams in the denominator, moles up top. That means I have 1 mole, and then my amount of grams when I calculated was 216.59. Hopefully that's the right number. And then we're done with our first conversion. And now we need to go from mole of mercury oxide to mole of oxygen. So mole of mercury oxide is in the numerator, mole of mercury oxide in the denominator, mole of oxygen on top. Let's take a look at our balanced equation. Our numbers are, we have a coefficient of 1 for oxygen. We have a coefficient of 2 for mercury oxide. So that is a 1 to 2. Check our units, make sure they've canceled and that we are where we're supposed to be, and we are. So you would take 517.84 divided by 216.59 and then divided by 2, and that should give you an answer of 1.1954 mole of oxygen. And that is the answer to number 2. So hopefully that was helpful.